You got introduced to the Pythagorean relationship. It has to do with the relationship between the side lengths in a right triangle. So if I can flip back to that really quickly here. You had lots of pictures of in the textbook of that looked something like this. And you learned that the relationship between the side lengths, you have to look at the squares of the side lengths, the squares that are attached to each of the sides. So if you want to know the relationship between these three side lengths, you got to look at the fact that those two areas add up to this area. That's the Pythagorean relationship. And you're going to use it. This one was just exploring it. Sure. Okay, so this first one was just exploring it and seeing what's happening. What you're going to do in this section now is use it to find missing sides. Okay? So if you're trying to sort out what the focus on is here, determine the length of a missing side of a right triangle using that Pythagorean relationship. If you know two sides, you know the third. This is a pretty important concept that's going to come up in a lot of different places. The picture they show over here is they're saying, if you know that this is 90 feet and you know that this is 90 feet, a baseball diamond, how far is it directly across, like from the catcher to throw it right to second base if they're trying to throw somebody out? It's longer, but you can use these two sides. Okay, so that's the idea that's going on here. I'm not going to do the questions that are in the study guide. We're going to do two of our own here. So this is why you need some of your own paper. And if you wanted to put, because remember, like when we do a warm-up next time and you say, I don't get it, I'm going to say, you can look back in your notes, right? You should write some things down to refer back to, okay? It's a good strategy. Yeah, but can we talk about that later? Oops, I forgot that we're using. It is not going to recognize this when I try to change it. Watch this. Wow, it's pretty close. C 3.4. Okay, so this has to do with right triangles, right? So we need a right triangle here. Let's try drawing a right triangle that looks like this. Let's make this. I won't actually necessarily make it to scale here, but why not? Let's make it to scale. Let's do that. And then we have this length right here, okay? If you have this length, this is 6 units, this is 8 units, and this is, we're going to say, unknown length, right? You can hold a ruler up to and measure it, but you need to be able to use the Pythagorean relationship to find missing sides here. If this is a right triangle, you know the relationship between those sides. I'm going to give this a name. I'm going to call it H for hypotenuse, if I'm trying to find the length of that side. Okay, so the first thing you want to do is you want to be able to write the statement for the Pythagorean relationship. Let's say write a Pythagorean statement. If it's a right triangle, then the squares on the two smaller sides. That squared plus that squared. You can draw the squares if it helps. Like you could draw the squares. Okay, you could say that square right there plus this square right here if you wanted to. We don't have to do it visually, but those two squares are going to add up to the other square. But I'd like us to be able to do it without necessarily drawing the squares at this stage. 6 squared is how many little squares that square is going to have, and 8 squared is how many squares the bottom square would have. I'm going to write h squared over here. H squared, because that's what this square over here would have. H times h, that square, if we had that whole thing drawn in there. If you want to work this out, then you just get your calculator, or you should know some of these numbers anyways. 6 squared plus 8 squared. What's 6 squared? 36. What's 8 squared? 64. A good way to work with this is to write the statement first, and then just slowly work your way down, okay? Rather than doing random scribbling all over, it's better if you write the statement and then you just slowly simplify it. Change the 6 squared to a 36. Change the 8 squared to a 64. Just make one change at a time as you work down. Keep the equal signs all lined up. It's a really organized way to show what you're doing. Then you can say h squared if you add those two numbers together. You got 100. If h squared is 100, something times itself is 100, what does that something have to be? What does something have to be? It has to be 10, right? If you're not sure, again, you can always go to your calculator, right? If it's a number that's not, 100 you probably know, but if it's a number you don't know, if it's not a perfect square, you can go to your calculator, right? And you can just do square root. Square root of 100 is 10, right? If you want, you can even say that here. H is square root of 100, right? If h squared is 100, h is the square root of 100. Okay, so that is, let's call that example 1. Finding the hypotenuse. What does the word hypotenuse mean again? Which side's the hypotenuse in a right triangle? Which one? Longest one, right? Absolutely, longest one. So what do we need to do for example 2 here? What do we need to do for example 2? If example 1 was finding the hypotenuse, the longest side, what do we need to do for example 2? What do you think? No guesses? What do you think? Finding one of the shorter sides, right? They call it the legs, the shorter sides of the legs. But we can put in brackets, shorter side. So if we have a right triangle here, we'll make this one where it's not necessarily so nice. So I'm going to take the grid away, and we will just do this, okay? There's that. There is, that looks sort of like on the screen a right triangle. Sort of. Okay, so let's say that this is 5, and this is 6. No, we want the shorter side, so let's say that this is, what does that look like? 8. This is our right angle. You have to be told that it's a right triangle or this doesn't work, right? Okay, good first step is to write down the Pythagorean relationship. We should use a letter to represent this unknown side. I would just call it A or B or something like that, or X. Maybe we'll call this one X, but it doesn't matter what you call it. Okay? Can you write the statement for that? It's one of the shorter sides now, right? So think carefully about what adds up here. Don't just automatically say 5 squared plus 8 squared, because why is that not true in this case? Why don't I add those two? Which squares add up here? The two legs. Like this is, I'm not going to draw, I'll draw them once here, but that square plus this square. Number one, I won't draw them because my squares don't really look like squares, but those two squares. If I want to find a shorter side, I don't add the other two squares. What am I going to do with the other two squares? Subtract them, right? So I'm going to write a statement that says x squared is equal to 8 squared minus 5 squared. If you really want to make your notes good, you might want to put a note about why it's a subtraction. Okay, subtract since you're finding a smaller side, one of the smaller sides. If you're finding the largest side, you add the other two squares. If you're finding a shorter side, you got to subtract. Okay, so you got x squared is 8 squared minus 5 squared. Then again, I think it's a good strategy to just slowly simplify it. Slowly work your way down. As in, change this to what is that equal to? 64 again. Change this to what it's equal to. What is that equal to? 25. Put a subtraction. If you subtract that, you get 39, right? Is that right? So it says x squared. Something times itself is 39. That one's not so nice, is it? The other one came out to be a nice 100, and you could just see what it is. This one doesn't come out so nicely. If you have a square that's 39, first of all, maybe we should think about what two numbers is it going to be between? If you had to estimate that. We're not going to estimate it, we're going to use our calculator, but if you had to estimate it, what two numbers is it between? It's got it, the number we're going to look for, this is between 6 squared, which is 36, and 49, right? Like if x squared is 39, x is the square root of 39. If the area of this square here, if the area of this thing is 39, the side length has to be the square root of 39. It's got to be between those two, right? If you thought about a number line here, right? If you have a number line that you have, square root of 39 is there, it's got to be between 6 and 7. It has to be between 6 and 7. Which one's it going to be closer to? Well, square root of 36, like square root of 36, square root of 49, which number is it closer to? It's got to be closer to this. It's going to be like 6.1 or 2 or something like that, right? You can go to your calculator. I don't need you to estimate it, but I'm going to put roughly equal to here. And go to the calculator now and see what it is. Square root 39, roughly 6.2. If we're doing one decimal place, 6.2. If you're doing two decimal places, 6.24. Let's say it's roughly 6.2. You can give your answer two different ways for these things. This number is an approximate answer. Approximate answer. It's good to put this down too, because this is the exact answer. The Greeks didn't have calculators, so they didn't do this. How do you think they left their answer? They just left their answer like this. They didn't have calculators. They just talked about that. They said the length of that is square root of 39, whatever that is. And they knew it was between 6 and 7 somewhere, right? You can give your answer either way here. I'd like you to know the difference. I'd like you to understand why I put exactly equal to here, but I put approximately equal to here. Why is that? Why did I put this squiggly equal sign here, but the straight equal sign above it? What do you think? Absolutely, I rounded it off, right? Like this is not, it's not exactly 6.2, I rounded it off. So you can give your answer either way there if you want. Okay? This unit you can do really well at if you do the work along the way. But if you don't, it's not going to be one that's just going to come together on the test, okay? We're going to do some units this year that are difficult. Even if you do the work, this is not one of them. If you work at this one, you can do really well and wrap up term one with a pretty good mark on this. Okay? Do you feel good about going into December? Can you get going on what you need to do for this? In this section, there's no explore the math or anything to do. There is a few questions again. Follow the textbook examples if you need some more help or a different approach to things. 2 examples to do, and then you can get going on the assignment, right? Fill in the key ideas and then get going on the assignment. You should be able to get a pretty good chunk of that done if you use your time, okay? If you don't use your time in class and you're not doing stuff outside of class, I don't see how you're going to get the course done. So you got to do at least one or the other, right?